Hello, everyone, and welcome to our compound reverted Geartrain project. My name is Sean, and I worked alongside Sam, Gabe, and Dylan. The goal of this project is to design and assemble a compound reverted Geartrain that serves as an actuator unit for a modular soft robot crawler. The maximum volume of the Geartrain is 3 inches by 3 inches by 3 inches. The output gear ratio must be somewhere between 11.9 and 12.1 to 1, and the gearbox must be connected to a 2.5 to 1 bevel gear reduction. Our design contains a 3 inch by 3 inch by 3 inch box, which is hollow at the top, with the motor housing in the rear of the box. All four gears in the gear train are a half inch thick and form a combined gear ratio of 12 to 1 for the gear train. A 10-tooth 0.375 inch outer diameter pinion gear labeled Gear 1 in red is attached to the center of the motor housing. Its teeth contact the teeth of a 40-tooth 1.313 inch outer diameter spur gear labeled Gear 2 in yellow. The pinion gear is mounted by a 2 mm diameter rod through the center of the motor housing, and a 4 mm diameter rod that goes through both sides of the 3 inch by 3 inch box mounts the 40-tooth spur gear. An additional 10-tooth 0.375 inch outer diameter pinion gear, labeled Gear 3 in green, is mounted on the same 4 mm diameter shaft as the 40-tooth spur gear, which forms a compound gear. Additionally, the teeth of the 10-tooth pinion gear make contact with the teeth of the 30-tooth 1 inch outer diameter spur gear labeled Gear 4 in blue, which is mounted to the gearbox housing by a 0.15 inch diameter rod going through the gear housing. Here is a video of the gear train driving the robot crawler when the motor is running. Let's slow it down for a second. The first 10-tooth pinion gear drives the 40-tooth spur gear, reducing its speed by a factor of 4. Then, the 10-tooth pinion gear mounted on that same shaft as the 40-tooth spur gear drives another 30-tooth spur gear, reducing its speed by a factor of 3. This drives the first bevel gear in gray, which drives the second white bevel gear on the horizontal axle. This ultimately drives the wheels. As you can see, the gear train drives the crawler on its own, but due to the absence of rear tires, there is very little control over where it travels without any guidance. Also, as shown, the gear train reaches a smooth stall as a hand is manually placed on the wheels. When paired with the second crawler from another team, the entire device was able to travel from the first gray tape marker to the second gray tape marker in roughly 5.76 seconds. Overall, the gear train met the assigned constraints for the project and enabled the crawler to operate smoothly with the motor running. One improvement that could have been made if more time allowed would be to reduce friction between the 42 spur gear and the motor, which would have decreased power loss.